So far we have seen how to program a computer, but not how computers interact with each other using networking. In the next series of videos, we are going to talk about how computers interact and what sort of protocol they use in order to make this interaction. We have seen a network protocol already, which was HTTP. And HTTP is used to transfer web pages between computers. And we have seen that HTTP uses a client, which is usually a web browser, and a server. And definition is that the client initiates the connection to a server. However, we are going to talk about what these two entities exchange when they are connected to each other. What's happening in here? And most importantly, what are the different protocols and how do you build on top of each other to make them have a connection? A way to think about this is with the OSI model. The OSI model tells us that in order to have a connection between the client and the server, first thing, they have to be connected somehow using a physical layer. So the first thing you have to do is to connect physically the two computers. This can be with a wire, a cable, an optic fiber, or it can be using Wi-Fi or waves, electromagnetic waves, or anything. The second thing you have to do is to make the two computers see each other physically on the same, not network, but on the same one-on-one interaction. This one-on-one interaction, usually we call that the link. And this is where something like the MAC address comes in. The MAC address is the address of the hardware of the two computers. So this client interface here would have a MAC address and the server would also have one. And that's admitting they are directly connected with a single wire, for example. However, it's not the case. In reality, when you want to access a server from a client, you are not going to be directly connected to them. You are going to go through multiple servers, which are going to send your request and forward it towards the actual server at the end. This is much more efficient than having every single client on the world be connected to every single server. Imagine the numbers of wires. So in order to do that, we have to implement a way to do networking. And this is what we are going to be interested in the next videos. We're going to talk about this network layer. On the top of the network layer, you can actually have a way to make sure your packet and all the data are reliably transferred from the client to the server and on the way back. This is done using several different protocols, and they are all part of the transport. On top of the transport, you can find multiple other things such as security, presentation, and session. But for all intents and purposes, we can say that what's above that is just all the application that you're going to use, whether that be a web server or it can be an email client, can be really anything that uses the network. So what's important to remember is that in order to send information to a server and get information back, the two servers have to be connected somehow. Usually they are not connected directly using a single wire. They are connected using a series of different routers, and we're going to see what it means. And your client can be in Toronto and it's one in Paris. And the two would be connected using a series of different computers. In order for your request to get to the server, you have to implement some kind of networking, and we're going to see how that works. And in order to make sure that your message reliably gets to the server, you're going to need some kind of protocols to make sure of that. And this is really what you have to remember for the OSI model so far, and we're going to detail some of these layers in the next videos.